bit like a science lab. Understanding the science of cooking helps you make food taste as it should. So why does food behave as it does when we cook it? And what's going on in our head when we eat it? Jellies. In this episode, enter a strange new world with an old friend or two. I'm going to show you why a chip is just like blackcurrant jelly and how to use these jellies to make exciting new flavour combinations. Plus, learn how to make the best bangers and mash on earth. First, what exactly are jellies and gels? Now, this one down here is we should all know. Almost the ultimate, the most famous childhood dessert of all. It makes this. The lovely wibbly wobbly jellies and cream. Now, these effectively are made with gelatine. Gelatine is extracted from meat and bones, basically by just boiling them up. Now, if you've ever made chicken soup or oxtail stew, you'll know after prolonged cooking and maybe reducing the liquid down a bit, you end up with a really sticky sauce. When it's cold, it actually sets it, it becomes a jelly. This is exactly what we use to set these. Gelatine is the original gelling agent and is still one of the commonest. Here's a sweet jelly we serve at the restaurant. It's made of beetroot but tastes of blackcurrant. You can make some savoury jellies like this one made from quail meat without adding any gelatine. It produces its own, the same sort of jelly as you get in meat pies. This is a sheet of jellied passion fruit juice. It's not made with gelatine, but with an unusual gelling agent extracted from seaweed. Gel is just the scientific word for jellies. You can gelatinize food using other agents apart from gelatine. This is chocolate jelly. We've made this using a powerful gelling agent, gelang gum, from a plant extract that withstands high temperatures without melting. And this is a jellied tea. Like all gels, it's just a state of matter where a small amount of solid contains a large amount of liquid in a solid-like form. Finally, we have what I think is the cleverest of all of the jellies we have here. This is a pineapple jelly. Now, you cannot set pineapple juice or fresh pineapple juice with gelatine. Pineapple contains an enzyme, a biological catalyst that effectively eats the protein, which stops it from setting. As we saw earlier, the gelatine itself is extracted from meat and bones, or effectively protein. There's a very simple way to demonstrate the power of this enzyme at home. Take a piece of pineapple, like this, and basically just cut a piece, not too big, but just enough so you can fit it underneath your top lip. Excuse the slurping noises. Okay, now, you need to leave this under your lip for 5 to 10 minutes. And what will start to happen is you'll get this very mild throbbing sensation, which then becomes stronger. My gums are now starting to throb. It's actually becoming a little bit uncomfortable. The enzyme is so ferocious, it immediately starts attacking the proteins in your gums, which soon get very uncomfortable. It would attack gelatine in just the same way. That's it. It's now throbbing quite strongly. Oh. Once you've done that, you really can see how it's very difficult for a sheet of gelatine, which effectively is protein, to set the juice made from a pineapple. So, I'm going to show you a technique which I discovered a couple of years ago. And effectively, by using this, we can make our pineapple jelly. First, take some fresh pineapple juice and pour into a pan. Meanwhile, take some sheets of gelatine that we saw earlier and soften them in cold water. Gently heat the pineapple juice and add to it 1 chopped capsicum, red chilli, seeds as well. This is the magic ingredient, as it contains a chemical that destroys the enzyme in the pineapple, allowing you to make the jelly. When the pineapple juice is warm to hot, Gently remove the gelatin leaves from the water. They should now be very soft. Squeeze the excess water off the leaves and carefully add to the pineapple juice. Now simply stir the pan until the gelatin is dissolved into the pineapple juice. Pass through a fine sieve into a bowl or mould of your choice and store in the fridge until set. This should take 2 to 4 hours. And then serve. Simple. So what's happening at the molecular level when we make gels like these? A gel's a network of long molecules, partially dissolved in liquid. Present in all jellies, this helps trap moisture in food as we cook it. And with the moisture, we store the flavour. All food's made of cells. Inside the cell walls, moisture, and inside that, molecules containing flavour. When we chop or cook food, we break down the cell walls. Flavour molecules are released, very light and very volatile. Flying up the nose, they send electrical signals to our brain, which then tells us we're experiencing aromas. Together with signals from the taste in the mouth, these make the flavour. A perfect way of locking flavour into food till we eat it is gels. Gels are everywhere. Marmalade's another gel. And once you add milk, so are cornflakes. And once you add hot water, so is spaghetti, which works as a gel by releasing not gelatin, but starch, just like rice or potatoes. Potatoes are full of starch, one of the commonest carbohydrates found in nature. Swollen with liquid, starch is a superb gel. Know the chemistry of starch gels and you'll revolutionise how you cook potatoes. Inside this potato are thousands of tiny starch granules. Now, our bodies aren't designed to digest these starch granules in the form that they're made by the plants, so we have to cook them, and we have to cook them in the right way. Now here, I've got a potato that I've pre-soaked at 62 degrees. And under normal circumstances, a slice of potato, you wouldn't be able to see the starch granules. But by this pre-cooking method or pre-soaking method, we can see them. So hopefully I'm going to cut a thin slice off of this potato and show you. And here we are, we can clearly see all the small granules of starch, some bigger than others, but there's loads of them in this slice of potato. And what's happened is the granules themselves have been swollen with water. Now, when we cut through the granules, the water leaks out. Let's have a look here. We can see some moisture on the surface of the potato. It might not look a lot, but believe me, the dams are bursting. As you cut, the walls of each granule burst and the starch escapes on its way to forming a gel. Each one of these starch granules is a mini jelly. And the key to cooking potatoes, whatever their usage, is keep the gels and the starches on your side. I'm going to show you how to make the greatest chips on earth. That is a sweeping statement, I know, but they really are sensational. Although we're using a couple of clever pieces of equipment here, you can follow a method at home that will revolutionise the way you make your chips. This is a desiccator, a fancy demoisturiser. After first cooking chips in water, we put them inside. It's connected to a pump which creates a vacuum and sucks the excess moisture out of the chip. You won't find this piece of equipment in a kitchen shop. It's actually a piece of scientific laboratory equipment. So you're probably thinking, well, how on earth am I going to get hold of a desiccator? Well, don't worry, all is not lost. The secret to making good chips at home is 3 cooking processes. Simmer the chips, cool them. Cook them in warm oil, cool them. Cook them in very hot oil, serve them. Simple as that. After boiling and cooling, you then fry them in warm oil, around 130 Celsius. So what we're doing now is there's been some starch built up on the surface of the chip after being cooked in simmering water. This now is being gelatinized on the surface during this cooking process, which will ultimately provide our crisp, really crunchy exterior. Then, after cooling again, fry them in hot oil around 190 Celsius. There you are, top-notch chicken and chips. Coming up, how to use the chemistry of gels to make the best mash in the world. As we've seen, there's a huge variety of gels and jellies, and there's even a host of gels inside the humble potato. I'm joined by my friend, flavour specialist, Professor Tony Blake. Hi Tony, how are you?
Heston.
I've got these chips. I wanted to have a little taste, see what you think.
These are the famous fat duck chips.
Fat duck desiccated chips. One of the world's leading chemists in food research. There's no one better qualified to give you chapter and verse on the chemistry of starch and gels and their impact on flavour.
You're really forming doing quite a clever piece of physical chemistry, because you're turning the outside of the chip into what we call a glassy state. Now, we normally think of glass as you get in window glass in the windows, but you can make glasses out of lots of different things. And in this case, it's a carbohydrate glass. And you've got some spaghetti here. And in fact, when you break spaghetti, as we all know, it cracks. And it's got a nice shiny surface. Now, that is a glass. And the skin on the outside of your chips is also a glass. Now, the thing about glassy materials is that they lock flavours in. And what you've managed to do here is lock a lot of nice fried chip flavour into the glassy outside. When we put food in our mouth, we have an expectation of texture which we relate to flavour. And texture has a dramatic effect on the way we perceive flavour. And I think this is what you're doing very cleverly here, is you're combining both textural changes in the food with flavour release changes in the food, and you're giving that certain extra something when you eat the chips that you make.
What I want to do now for you is I'd like to cook some mashed potato. Two different ways. I'd like you to taste the difference between the two, see what you think. See, hopefully play around with some of the starch in each one, and, well, you tell me.
OK.
So here's the bad mash. And here's the good mash. Can Tony tell the difference? OK, Tony. So here are two warm gels. Take your pick.
OK, Heston, let's have a go at them. Yeah, I like that one personally. I'm not quite sure about the other one. Let's try the other one. Yeah, Heston's on his way to wallpaper paste. This Heston is definitely the one I would go for. This is nice. It's got a nice granular texture, good flavour.
I've got quite a lot more of that one if you want it.
No, you paper your lounge.
So which one are you going to go for with your bangers?
This one. This one.
OK. There you are. Such good gels, there's no need for the traditional extra.
Very good.
Some ketchup?
No thanks. No ketchup.
I'm going to show you how we made that good and bad mash that Tony ate the other day. The secret here is the gels. It's making the gels work for you, not against you. This is really vital, really vital. What we're trying to do is stop the starch from being forced out of the potato and create mayhem, ending up with a gluey, wallpaper paste textured puree that none of us would like. The potatoes for the good mash are given a warm pre-soak at 62 Celsius for half an hour. That locks the starch into all those little granules inside the potato, so it can't leak out and turn your puree into one big, horrible, starchy, gluey gel. I then plunged both lots of potato into pans of salted water and left them to simmer till ready. Okay, now I'm just draining the potatoes, get the excess water off, tip them into a bowl, and just pour cold running water over them until they're cold. To puree them, I put the potatoes through a ricer a very handy gadget just like a large garlic press, only 10 times bigger. This destroys far fewer granules than a food processor would, so you can puree the potato without releasing so much starch you create a big gluey gel. I'm just ricing them over the bowl of butter, cold butter. Now we're using here 50%. You don't balk at this. You can reduce this down to 30% if you want to. But really, for really luxuriant puree, 50% of butter is good, and you don't have to do this too often. Just have it as a treat. So now I'm stirring the potatoes and butter in. The heat of the potatoes will melt the butter. That's fine. So they're now mixed. Now all we need to do is take a drum sieve, which looks a bit like one of those gold prospecting sieves, and I'm just pushing the puree through that with a scraper, flat scraper. The beauty with this is once I've passed this through, it can then be stored in the fridge, simply reheated when needed with a little bit of water. A wonderfully smooth, silky texture to it. To finish the good mash, I now whisk in some simmering milk until it's smooth and silky. That is a good gel. I'm now going to make the bad gluey wallpaper paste that sometimes people pass off as mash, but no thanks. For this, I take the potatoes which didn't pre-soak to lock in the starch, and I pour them into the food processor. I've got the same amount of butter. I've just poured the hot potatoes onto the butter, put the lid on, and just process away until pureed. I now add some simmering milk again, but as the potato in this mix wasn't pre-soaked, it's still full of starch and water, so we get a puree that can't be stored and tastes vile. I've just made wallpaper paste. Oh boy, that is one bad gel. To learn more about gels and what they can do, I've come to Switzerland. This is Firmenich in Geneva, one of the world's biggest manufacturers of synthetic flavours. I come here whenever I can to catch up on some of the latest research into the science of food and experiment on kitchen chemistry with scientists here. And this is one of my favourite labs in the Food and Flavour Expertise Centre. It's where they study viscosity, the thickness of fluids, and how to stabilise mixes using gels. This is chemist Alan Parker, a world expert in gels. Many of these bottles contain super concentrated gels, enough to make tons of the products they're designed for. This one's for a soft drink.
Don't swig it.
Oh.
It's good, isn't it?
Yeah. I often come to Alan with practical problems of kitchen chemistry. For example, normally mayonnaise breaks up and separates out as soon as you heat it. So, a challenge for Alan. Could you make mayonnaise that would not split when you heated it up?
Well, let's try it, eh?
Here on Alan's recommendation, I'm adding some xanthan gum mixed with guar gum to one sample of the mayonnaise. The other sample is free of any gelling agent. Xanthan and guar gum are both composed of long strings of sugar molecules. Will they prevent the mayonnaise from breaking up when we heat it? This is the one with the gum in it.
And it's just sitting there like a sort of poached egg, I think, isn't it?
Whereas this one, the pan's actually cooler, quite a bit cooler. That's got no gum. Look,
It's
that's split.
spreading out and... Yeah.
Look at the oil in there. Hey.
Are you convinced?
Success. I think actually it's a genuine success.
This time?
For once.
For once, no.
So we found you can use a gel to make hot mayonnaise, something I may well incorporate into future menus at my restaurant. And now for something special, crab risotto. Now, this dish involves two gels, the first being the risotto and the second being the sheet of passion fruit jelly that separates the risotto from the ice cream, enabling us to put a crab ice cream on top of the risotto, but without allowing it to melt too quickly. Now, this dish for me was my initial entry into the world of the psychology of flavours. The crab ice cream, being savoury, tastes of crab, but because the brain's telling the palate it's ice cream, you subconsciously are prepared for sugar, and you almost pick up a sweetness that isn't there. It's quite fascinating, and it's a really good way of playing with the senses.
First, pour the crab stock into the pan. When simmering, add a portion of half-cooked crab risotto, made from toasting superfino rice in olive oil, adding veal marrowbone, chopped shallots, garlic and white wine. Add a ladle of stock at a time. When this is just about reduced, add another ladle of stock and repeat. Do this about half a dozen times until the rice is cooked. It should have a little resistance in the centre of the grain, but no chalkiness. Then add a teaspoon of mascarpone cheese and a handful of rocket. As the risotto nears the end of the cooking process, the sauce thickens as the starches gelatinize, and the rice grains are coated with this thickened starch gel. Then, beat in grated parmesan and butter. As the fat melts, the starch gel helps the fat disperse. This further thickens the sauce and prevents the fat from separating. Then add white crab meat, followed by the crab velouté, a thick aromatic sauce made from brown crab meat and stock, plus alcohol and cream, reduced down. Add some shredded basil. Finish with a few drops of lemon and orange juice, oil, salt and black pepper. Leave the risotto to thicken for a couple of minutes. Now to plate up. Beside the jug of powdered red pepper, a spoonful of risotto, the dish's first gel. Add a thin red line of red pepper reduction. Cover the risotto with a sheet of passion fruit jelly, the second gel. This only melts above 80 Celsius and protects the ice cream from the heat of the risotto. Then, the crab ice cream. A few drops of crab oil. And there you are, crab risotto.